Hi students, welcome to preliminary chemistry and the energy topic. This is video number 13 on ignition temperature and pollution. We looked at a couple of terms previously when we were studying hydrocarbons, and those terms were volatility relating to the vapor pressure of a particular substance that sits above its solid or liquid phase, and also the flash point, which is the point at which it can um, uh, respond to a spark. Ignition temperature is the lowest temperature at which a substance actually starts to burn. So this means that you don't actually necessarily need a spark. All you need to do is to just start to warm the substance. You'll know that that's the case with, say, something like paper. We don't need to spark paper. All we need to do is just to warm it, and it will start to burn. The lowest temperature at which that process begins is called the ignition temperature, and that's the temperature at which the substance ignites, literally. So there's a direct link between the ignition temperature and the activation energy of a reaction, particularly if we're talking about combustion reactions. The higher the activation energy, the higher the ignition temperature. So these two are directly proportional to one another. If the ignition temperatures are relatively low in comparison to, say, between diesel and petrol, diesel has a lower ignition temperature, then it may simply be sufficient to compress the fuel and air mixture in order to reach that ignition temperature. We may just, if we just squeeze them close enough together, then sufficient temperature may have that reaction, that combustion reaction happening spontaneously. However, if the ignition temperature is higher, which it is for something like octane in petrol, then this method is not as safe. And instead, what we do is we use the spark. So we use that concept of flashpoint to ignite the fuel mixture rather than just to fuel air mixture rather than just to allow it to spontaneously react. One of the problems that we have, of course, when things start to combust is that they can release different types of pollution. Now, we looked at the difference between complete and incomplete combustion in one of the earlier videos. And one of the problems with incomplete combustion is we get two forms of pollutants, one of which is a respiratory irritant. In fact, both can be regarded as respiratory irritants. But the problem with carbon monoxide is it also has an effect on our hemoglobin. One of the problems is it binds in the same place as oxygen does. So therefore, it will reduce the oxygen carrying capacity of our blood. So that's not so good. And the other one is soot, which is particulate matter, carbon in its solid form, which creates a form of pollution. Now, of course, these are not the only sources of pollutants during combustion reactions. Any waste products, anything that's around comes under that general definition of pollutant. Anything that we don't want in a particular environment, in the air or in the water. Waste products, poisons, fertilizers, all of which can be released into the air or the water or the earth, and they have some impact on the environment, not only on its visual appeal, but also on the organisms that rely on it. It contributes to such phenomena as soil degradation, a breakdown in the quality of the soil, eutrophication of waterways, the excessive growth of plant material, and also a drop in the pH of rain, becoming more acidic, and this also has some significant implications. When any fuels combust, they often are releasing unwanted products into the atmosphere, and this can be carbon monoxide, this can be carbon as particulate soot, it can be oxides of nitrogen, it can be oxides of sulfur, and so on. There's all sorts of different things that could be present in the fuel sources when they're combusting. Even in complete combustion, where we have carbon dioxide and water as our products, we know that carbon dioxide is one of these substances that contributes to global warming. There's plenty of evidence for that. I'm not trying to convince you. It's not about belief. It's about accepting the evidence, and that's what we do as scientists. What we also try and do is to minimize that or investigate ways in which we can limit that. Having said that, carbon dioxide in the atmosphere is preferable to some of these other products like carbon monoxide or carbon. So therefore, trying to ensure that when fuels are combusting, they do so in high rather than limited oxygen environments can limit the potential impact on the atmosphere in particular of these environmental pollutants. The other thing, of course, that can happen in incomplete combustion is we may actually not have all of the hydrocarbons themselves actually burning, which means that the hydrocarbons can also be released into the atmosphere that have not had the chance to combust, and that also can act as a pollutant. Just a few of these other ones that we just quickly tick off. The oxides of sulfur are, of course, primarily sulfur dioxide and sulfur trioxide. You can have hydrogen sulfide, which is known as rotten egg gas, that can also be released at times. Sulfur dioxide is colorless but very poisonous, and it either being soluble in water or being oxidized to sulfur trioxide, which is also soluble in water, can result in the formation of sulfuric or sulfurous acid, which significantly drops the pH of rain. This is also the case for oxides of nitrogen, which form a form of nitric or nitrous acid, and they too can have a very significant effect. Nitrous oxides have also been linked to photochemical smog, which is another dangerous kind of pollutant. And particulate matter is basically fine particles like ash or soot, such as particles of carbon that you see flying off even when you just burn timber, for example, but can also be released by car exhausts and power stations. Most of the stuff on pollutants shouldn't be new to you. I'm sure you've discussed pollutants in the past, but it's important to have a couple of specific examples that you can pick and choose from, and specifically those that relate to incomplete combustion. Thanks for watching.